This is a third video on section 1.1, and we're going to talk about the distance formula. And the distance between 2 points, x1, y1, z1, and x2, y2, z2 in 3 space is, the conclusion of the theorem is the square root of x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. And this distance formula is based on the Pythagorean theorem. And we use the Pythagorean theorem twice. So if you remember what the Pythagorean theorem says, that if you have the sides of a right triangle, where C is the hypotenuse, or C is the length of the hypotenuse, A and B are the length of the legs, then A squared plus B squared is C squared. So we're going to start with our 2 points in 3 space, x1, y1, z1 right here, and x2, y2, z2 right here, and we'll call the distance between them C. Now this is a triangle in 3 space. This side has length A, and this side here has length B. But if we're going to think of this as the vertical distance along the z-axis, then this is simply the difference, or the absolute value of the difference of z1 and z2. So this is the absolute value of z1 minus z2. This is the difference in height of the 2 points. So the 2 points are hanging out here someplace, and this is the difference in the height. So this is the part we're calling B, and so this is the absolute value of z1 minus z2. Another way to write that is the square root of the quantity z1 minus z2 squared. This is just another way of writing the square root. So now we want to find the length of A. So what we do is we look at projections. I know projections come into example 9 when we talk about projections in more detail, but basically we project these 2 points onto the xy plane. So now we look at the point x1, y1, 0, x2, y2, 0. So now we've put these on the xy plane that we're nice and familiar with. And so again, we use the Pythagorean theorem. Now this time A is our hypotenuse along here. This distance here is simply x1 minus x2 or x2 minus x1, whichever's positive. So we just take the absolute value of x1 minus x2. The way I've drawn this picture, x2 is larger than x1. So this is really just x2 minus x1. This here, this is going to be the absolute value of y1 minus y2. The way I've drawn the picture, y1 is greater than y2, so this is just y1 minus y2. Absolute value, again, another way to write that is the square root of this quantity squared. We did the same thing with the x's. And so, what is A? Well, again, we're using Pythagorean theorem because now A is the hypotenuse of this triangle. So we have this side squared plus this side squared is equal to A squared. So we take the square root to get A. Again, another way to think of this is just the distance formula in the plane. So now A squared plus B squared is C squared. Remember? A squared plus B squared is C squared, and C is what we're looking for. What's A squared plus B squared? Well, the B squared is just the z1 minus z2 squared, and what's the A squared? Well, we know that this is A right here, so A squared is this term under the square root squared. So we just take this, just take the square root away. This is the A squared part right here. This is B squared. So we want the distance. So A squared plus B squared, this is C squared. So what is C? It's the square root of this. So this is how we have the distance formula.